What if pi to the power of pi to the power of pi to the power of pi were an integer? A question that might seem bizarre at first glance, but one that beautifully captures the enigma that is the world of mathematics. Dive into the world of transcendental numbers, and you'll meet pi, a number that's irrational but also transcendental. This means it doesn't root any polynomial with rational coefficients, yet there's no concrete proof that it couldn't be the root of a polynomial with integer coefficients. You see, there's a multitude of transcendental numbers out there that do just that. Now imagine pi raised to the power of pi raised to the power of pi raised to the power of pi, a number so colossal that even our current computing power falls short of calculating its exact value. Could such a gargantuan number be an integer hidden behind a long, winding decimal representation? Quite possibly. However, this doesn't mean that pi to the power of pi to the power of pi to the power of pi is definitely an integer. If it were, we should be able to express pi as a ratio of two integers. But we know that pi is irrational, and this irrationality extends to pi to the power of pi to the power of pi to the power of pi as well. So, is pi to the power of pi to the power of pi to the power of pi an integer? Well, until we have proof, it remains a tantalizing conjecture, a question mark hanging in the mathematical universe. Now let's turn our gaze to some other transcendental numbers that are roots of polynomials with integer coefficients. The square root of 2 is the root of the polynomial x squared minus 2. The number e is the root of the polynomial x squared minus e. The square root of 3 is the root of the polynomial x squared minus 3. These examples illustrate that transcendental numbers can indeed root polynomials with integer coefficients. However, remember that these are just a handful of examples. The universe of transcendental numbers is vast and largely unexplored. There are countless other transcendental numbers out there, still waiting to reveal whether they root any polynomials with integer coefficients. So, where does this leave us with pi to the power of pi to the power of pi to the power of pi? Well, in the realm of conjecture, with a tantalizing question about the nature of this number, the mathematical world continues to ponder, to explore, and to marvel at the mysteries of numbers like pi. And perhaps in this quest for knowledge lies the true beauty of mathematics.